In the last section of this unit, we're going to use proportions to solve percent problems. So I think it's pretty important that we review how to solve a proportion really quick. So in number 1, to solve for C, I would start by cross multiplying. So let's see, 9 times 28. So let me get out my calculator. That's going to be 252. And that's going to be equal to 4 times C, which is just 4C. And then I'll divide both sides by 4 to get a value for C. And it turns out C is equal to 63. And then in number 2, I notice that I have not only the n up in the numerator, but also in the denominator. So that's going to tell me that when I cross multiply, I'm going to have variables on both sides. So I'll do 9 times n, which is just 9n. And then 5 times n minus 7, and I'll make sure to use parentheses. So n minus 7 here. I'll go ahead and distribute the 5. So 5 times n is 5n. 5 times negative 7 is negative 35, or minus. Bring down the 9n. Now I want to get my variables to one side, so I'll subtract 5n over here. Subtract 5n, and so that gives me 4n is equal to, making sure not to drop the negative in front of the 35, so negative 35. And then 35 divided by, or negative 35 divided by 4, will give me negative 8.75. All right, so there's your quick recap on proportions. So, percent's probably one of the most valuable thing to remember how to do, because when you go to a restaurant and you have to tip your waitress, which you should always do, 20%, but then there's always tax, which can range between, 7%, 8%, depending on where you are, or less. This is a valuable life skill. So when we, first of all, let's answer the question at the top. What are percents normally out of? Percent literally means out of 100, okay? So you can use this general form, so an unknown percent over 100. So that represents our percent equals is over of, and that may or may not sound familiar to you. Hopefully it does. So let's kind of practice using this proportion over here in our chart. So when we're finding a percent, that's where we're always looking for the unknown over the 100. If I don't know my percent, what over 100? So what percent of 252, so it says of 252, that's going to go down here, is 84. So that would go up here. So I'm not going to actually solve this, but I'm just showing you how I would set it up. So what it would look like if I'm solving for a percent. If I'm trying to find a part of the base, so it says what number is. What number is. So I don't know my is. So that's where my x is going. But it says what number is 30%, so I know my percent. So I would put 30 over 100, okay? And actually, I want to kind of go back to over here, and right over here, and I want to erase this x, and what I should have put was percent. Percent over 100 is over of. So back to the problem over on the right, it says what number is 30% of 90, so 90 would go here. And then finally, if we're trying to find the whole, or what we call the base, or the of, what would that look like? So again, it says 16 is. So 16 goes in the is, 20%, so in this case I know my percent, so 20 over 100, of what number? So the of is the unknown. So now that we've kind of had a few examples of how do we set this up, let's apply that to some examples down here. So it says what percent? So if I don't know the percent, that's going to look like my first example. So x over 100, so I don't know my percent. So what percent of 50? So 50 is my of, is 33. So that's how I would go ahead and set it up. Then I would cross multiply. I would get 50x, multiplying these two, is equal to 3,300. I'm multiplying 33 and 100. And then I would simply divide both sides by 50. And let's see, x is equal to 66. And that's it. That would be 66%. So number 2, what number is? So what number is my unknown. So I have my equal sign. My unknown is. I know 75%, so 75 over 100 of 164. So I can go ahead and cross multiply. So I have 100x is equal to, and then let's see, 75 times 164. So let me just make sure I did that right. Is, I don't think I'll be able to fit this down here. So I'm going to put it over here. So 100x is equal to, that comes out to 12,300 when I multiplied 75 and 164. Then I'll divide both sides by 100. And I get that x is equal to 123. And then finally, number 3, all the way at the bottom here, I don't know if you guys can see it. So what I'm actually going to do is I'm going to erase my work for number 1, just so I have somewhere to write my work for number 3. So for number 3, it says, well, what percent? Okay, so I don't know my percent. So x is over 100 of 76 is 57. So then I'll go ahead and cross multiply. So 100 times 57 is 5,700 is equal to, and then x times 76, so 76x. And then I'll go ahead and divide 5,700 divided by 76. And that gives me an x value of 75. So how can we apply this to some real life scenarios? So in number 4, it says Maddie is about to take finals and wants to get at least of 85% on the final. If the final is going to be 123 points, how many does she have to get right in order to get at least 85%? So technically this is an inequality problem, but we're not going to look at it like that. So I want to find 85% of 123 points. So 85% of 123 is how many points? So then I'll cross multiply and get 100x is equal to, and then I'll do 85 times 123. And that gives me 10,455. And just double check that, 85 times 123. Yep. And then I'll divide both sides by 100. And we get x is equal to, let's see, 104.55. Now, I guess I could technically get a half a point or half a question correct, but let's say they don't do any half points. If I'm running it to the nearest whole point, I would want to make sure I get at least 105 questions right to ensure I get an 85% on the final. Then in number 5, this is a great application problem because we're going to compare 2 different stores. So in store A, there's a bike on sale for 20% off the original price. So to figure out how much I'm going to save, I got to find 20%. So 20 over 100 is equal to, so of 240. So from here, I'm going to figure out, by doing this, I'm figuring out how much is coming off of the price. So I cross multiply and I get 100x is equal to 4,800. Whoops. And I'll divide both sides by 100. And I get that x is equal to 48. So 48 is how much that's coming off, okay? Or that's how much money I'm going to save. That's not the price of the bike. So in part B, it says, well, at another store, the same bike is on sale for 25% off the original price, but the original price is a little higher at $265. So let's see, what is 25% of $265? Okay, so 25 over 100 equals x over 265. Cross multiplying, so 25 times 265 gives me 6,625. divide both sides by 100. And I get that X is equal to, and then we're talking money, so I got to use my units, 66.25 or $66.25. Okay, that's how much I'm going to save at store B. Now, interesting. So C says, well, which bike should you buy? Okay, so right off the bat, maybe we think that, oh, well, option B or store B is the best one because I'm going to save more money, but it costs more. So let's actually figure out how much I'm going to actually purchase the bike for at each one. So at store A, so I would take $240 and I'm going to subtract $48. Well, that gives me $192 is my total. Okay, so then I'll take option B, so $265 minus $66.25. So that's going to give us $198. Whew, $198.75. Okay, so I'm actually going to save more at store B because I'm not only getting more off, but then my final price is less.